So today I'm going to talk about the final exam for mce180. I'm going to talk about how it's split up and what you got to do. Okay, there's a take-home part and a in-class part. So I'm going to talk about these two pieces. Then I'm going to talk about how you're going to submit this on Oswald. And after I talk about that, I'm going to actually do a study guide to show you exactly what you're going to have to do from start to finish, every single step. The first part is the take home part, okay? And you can start that really at any time. If you go to the mce180 folder on the Google Drive, there's a final exam folder and it's going to give you all these files. The first file is a video, okay, showing you what you're going to build, all right? And you are given a drawing file to create a drawing, a JPEG rendering of your model, the instruction sheet that you see right here, okay, and the drawing, and a drawing. So this is the take-home part. Okay, so anyways, let's talk about how you're gonna start this. Okay, so to start this, here's what you're gonna do. First, you open this drawing, okay? You open this drawing and you model this object. And again, I'm going to show you how to do that in just a second, but for now, understand what you got to do. You got to read these dimensions and you got to build it, just like we learned with exercise with the features 1 and 2 exercise, okay? Or homework 4. So, you read the dimensions, you do your extrusions, you use the whole wizard and you build this. After you have a model, it's going to be an SLD, PRT, SLD PRT. Once you have the model, you're going to create a drawing. You create a drawing by downloading this file and importing this model that you built onto the drawing, and you're going to recreate this. So you're going to use the project tool to display that there. You're going to use the dimensioning tool for that. You're going to add the notes. You're going to update the template just like we've practiced over and over again. So let's talk about this drawing file here. When you open it, it's got two tabs, part and assembly. It may even say part drawing or something like that on yours, but that's what it is, part and assembly. It's just two drawings on one binder. When you do a file save as PDF, it's going to create a single binder that's going to combine your two drawings. That's why there's the two parts. But anyways, for the take-home part, you're going to read this drawing, you're going to model this object, and you're going to import this object onto this drawing. You're going to do the projections, you're going to add the dimensions, you're going to fill out the template, all those things. And that's what the take-home part is. So that's the take-home portion. Now let's talk about the in-class portion. So to do that part, you have to log in into the app. Okay, so let's say you have to do this right before the exam starts. The exam starts right before we usually meet. So in this semester, which is spring, this is just an example semester with bogus numbers, but let's say we are taking this final exam for the spring 2020 semester. So we usually meet at 4 to 5:50 during this semester. Okay, 4 p.m. to 5:50. So what that means is that at 4 p.m. you're gonna see a tab here for fe01, the final exam 01. Right now, if you log in, you're not gonna see it because it's not 4 p.m. yet and it's not finals week. But at 4 p.m. you're gonna see this exact tab. And let's take a look to see what we're gonna get when we click this tab. So first let's talk about the files here. These files are pretty much the same files that you see here, except you have an extra file here. It's called parts.zip. So when you download that, it's gonna look like this. Okay, it's a zip and you gotta extract it. So you can hit extract to parts and it's gonna create a folder with a bunch of parts that you're going to import in an assembly. It may when you try to download it, it may give you like a pop-out error notification. Just click OK. Just say, yeah, that's okay. It's okay to download from the app. So you can get all these parts, and you're gonna create a new assembly. Okay, in SolidWorks, you're gonna go File, New Assembly, and you're gonna import each of those parts inside. Well, you may say, well, how do we assemble it? Okay, what do we put where? Okay, that's going to be described on this file. If you click this file, you're going to notice that there's a second page to it. Okay, there's 2 pages. This was for the take-home part. This is for the in-class portion. And in the second page, it's going to show you, all right, which part goes where. I'm even giving you a video, right? Remember, you also have a video, so you can clearly see how this thing comes together. The only thing is you don't have the parts now. You will only get the parts during the time of the exam. So once you get the parts, you can create this assembly. So you're going to import, you're going to add the explosion view, you're going to add the explosion sketch lines on your assembly. So it's going to be a .sldasm, and you're going to save that file. So once you have the assembly file all completed, guess what? You remember that drawing that you were working on? Okay, you did the first part at home. Now you're going to go to the second tab, and you're going to import your assembly and make it look exactly like what you see here. So you see what I'm trying to say? You're pretty much replicating this binder. All right. Every detail, the more you can make it look like this, the less points off you will get. Okay, so try to make these columns look exactly the way they are. Try to make the assembly lines, the balloons, look exactly the way they are. Don't worry about the numbering. Okay, if this is 12, if this is 8, it doesn't matter. Numbering doesn't matter. And even if you want to change that, it's very easy. But you're not gonna get points off for that. You're gonna get points off for making sure that some of these items look the way they do. And again, you have the error cards. So if you remember on the error cards, if you download this, you're gonna get something that looks like this. And this is for the final exam. Okay. These are all the error cards, so you can find them here, but you don't want to really dig through these and try to click each tab one at a time. So what I do is I go to the home, and I know that, for instance, I need U15. 15. There it is. General modeling. Okay, so this is a hyperlink. I'm sorry. Well, okay, let's go back to the index. 015. I'm sorry. 015. So you click the hyperlink, and it's going to tell you what am I gonna look for. Okay, these are the things I'm gonna look for on the final exam. So the error cards are going to correlate exactly to this old grade sheet. So let's take a look at this old grade sheet. If you go to final exam number 01, those codes, remember those codes that I mentioned on the error cards? They're right here. And the old way of how my exams were graded is my TAs would go in here and they just look at each of these items and see how you do. Okay, maybe you didn't do so hot on that error card. Okay, and then you know, my TAs would keep doing this, and what you get in the end is your grade. It would just calculate, and you can look through the equations, all right, to see how I set this up, to see the weights and all of those things. But that was how my exam was traditionally graded. But nowadays, I built all these algorithms on Oswald that does most of this automatically. But if you're trying to get an idea of what I'm looking for, you know, this may not be a bad place to look. Okay, so now that you understand what the final product is, let's talk about how you're going to submit this. There's 3 things you got to do. 1, 2, and 3. And then you got to hit submit. Okay, so let's talk about each of these. First one is an exam modeler. Okay, it means it's examining a model. So what you got to do is, after you build the model from the take-home part, you got to enter the volume, area, center of gravity, or mass. It's the same thing. Center of gravity and mass are the same thing. Okay, so you fill those out. Those are found in the SolidWorks Mass Properties tool. Okay, so if you click Mass Properties on the search box, right? You remember in SolidWorks you got a search box. Type in Mass Properties. Right now it's not going to show up because I'm on a drawing. I'm not on a part file. If I'm on a part file, it's going to show up. And when you do that, yeah, actually I probably should do it just so you understand. Okay, so let's say I was in a part. Let's have mass properties. Okay, and here's the numbers. Volume, surface area, center mass. You plug in those numbers to 5 decimal places. So if you can't get 5 decimal places, you can hit options and you can bring this up to 5. And here's what you get, 5 decimal places. So put in zeros just like that. And that's what you fill out. Make sure to hit save. Okay, you hit save. Then you return to the previous screen. Okay, let's take a look. And you have a second examiner. Let's see what that one looks like. Okay, so it's just like homework 5. You this is looking at the model of the assembly, and it has to look like this. Whatever you put in here has to look exactly like this. So you're going to suppress some items so it looks like that, and then do the same thing. Fill out the mass properties. You hit save, and then you return to the menu. Okay. And then the third part is the binder, the PDF binder. It tells you it's the PDF, it has to be less than 0.9 megabytes. And you have to browse for that file, and it should look exactly like this. 2 sheets. Okay, 1, 2, 2 sheets on 1 PDF. And you replicate this, okay? You try to make it look exactly the way it's supposed to look. And then you hit submit. If for some reason you're running out of time and you cannot get your PDF going, you can hit the bypass button. But you're going to lose all the points for this binder. So here, if I remember right, this is how it's broken down. If you submit anything in the class, you get at least a 50 for trying. But for the remainder 50, okay, it's distributed between these 3. So I think this is 10 points. These 2 are, I don't remember, like 20 points each. I think these are 20 points each. This one's 10 points, so that comes out to 50. So that's kind of how that's distributed. Another thing that you got to keep in mind with this exam is the due date. So the due date is going to be the time we usually finish class. So during this semester, which is spring 2020, class finishes at 5:50. So that means that right at 5:50, you're going to lose 3% per minute. So the first minute it's late, it's 3%. The highest you can get is 97%. The second minute it's late, okay, it's going to be minus 3%. Okay, so 94. And so on. So after 3 minutes, you almost lose a letter grade. So make sure to submit before whatever date is shown here. And it should be consistent with the time on your phone. So that should be consistent. It will also give you a modal. As soon as you start, you'll get a giant modal that will tell you, hey, this is when you got to submit it. So make sure to stay on top of that. So what I'm going to do now for the rest of this video is actually complete this whole exam from start to finish. So you understand exactly what you got to do during that hour and 50-minute period. So all these files are located here on the study guide number 2. And this is just one of my old exams, and I'm going to do exactly what you're going to be doing for this exam. Only difference is I'm going to do it on a Geneva cam. So this Geneva cam is going to run like this, okay? This was one of the older ways of timing before like robotics and, you know, motion controllers were invented. This is how they were able to maintain a delay in automation. Because think about it. In older ways of automation, all you had is a rotating motor. And with that, you got to do all the synchronization and delays and counting from a rotating motor. And one of the ways this was done was by using link bar systems or a Geneva cam, like what you see here. So what we're going to do is actually exactly what I just showed you a couple minutes ago. We're going to create a part drawing We're going to create an assembly drawing. We're going to put them together, and we're going to do this whole exam from start to finish. Okay, so we're going to start with the take-home portion, which is the very first part of this exam. Again, this instruction sheet is on the Google Drive. I already talked about that. This is broken down a little differently than what you'll see in with your final exam, just as far as like where the drawings are and how it's split up, but essentially the structure is the same. I mean, you'll find this drawing as a separate PDF on the final exam and things like that, but the process is pretty much identical. It's just the documentation looks a little different. So anyways, I'm gonna start by creating a part, and what I'm essentially trying to do is build this. So if you remember, since we started talking about SOLIDWORKS towards the second half of the semester, when you model, you usually start with a sketch, and I'm going to use the top plane just because this is a relatively flat object, and from here I'm going to draw the sketch. So I'm going to hit Control 8 to stay normal too. So really a lot of the things I'm going to talk about today is going to be kind of repetitious. Just going to hit this square center rectangle tool, okay, and I'm just going to draw. And again, remember, make sure you're in inches, pounds, and seconds, and make sure that you are using the ANSI standard. So make sure this is saying ANSI. Alright, so guess what? We're going to look at this drawing here, and we're going to build this. Okay, so as you can see, this is 8.663. Let's see what this is here. This is 4.88, and as you can see, the lines are all black. I don't want to see any blue lines. Again, remember, we need everything to be fully defined, meaning I cannot drag this. Okay, I cannot move this because it's defined. Also, did you notice the origin? I snapped my rectangle to the origin. Pay attention to that. That was very important. From here, I'm going to run the extrude tool, and we're going to extrude 1.5. See this? 1.5. Okay. So, sorry. I'm going to click extrude. I'm going to click the sketch. You can select it here or from the drop down. You can select it either way. And we're going to click 1.5, and that's it. Blind. It's not symmetrical, so it's blind. Alright, next thing I'm going to do are these two pockets, and it's just going to be exactly like features 1, I think. So again, I hit Control 8 to stay normal too. And I'm just going to draw two rectangles on here, just like you see on the drawing. I'm going to use the center line and snap midpoint to midpoint, because that's going to anchor it, that's going to restrain it. So that's all black. And then I'm going to use that symmetry trick. I'm going to hold shift, select these three items, and then see point, line, point, and then I'm going to hit symmetric to make sure it's centered. And then I'm going to hit the smart dimension tool and make sure that these are doing alright, which is 3.750. And then this is going to be 1.5. Again, I'm just reading these numbers. That's it. And again, I'm done when this is all black. And remember, these green boxes are relations. You can delete them or add them any way you like. Okay, so this is just saying this is a vertical relation, meaning this line cannot be at an angle. It's got to be vertical. So anyways, we're done with that, and now we're going to run the extrude cut tool. And you don't have to math anything out. You don't have to do this minus that or whatever. You can plug and chug every number that you see here. And I encourage you to do that because you'll make less mistakes. But in this case, I'm going to do an offset from surface. It's going to be an offset from this surface. And it's going to be, we're going from the top. Okay, you see it's offset from the bottom, so it's 0.75. So we're going to type in 0.75 and we get that exact depth. So you see how I did that? I did that with the offset from surface. And now we get a very nice cut. Next thing I'm going to do are these reliefs. See those reliefs? If you looked at one of the slide decks in designing for machining, the reason we have a relief there is because it's very difficult to machine a straight, a square corner like this on 3 planes. On 2 planes it's fine, but when it's on 3 planes, it's very difficult, and I talked about that. So So to combat that, if you remember on that slide, I said you can do this multiple ways. You can place a relief, or you can add a fillet that bumps up the end mill. You can read that slide on your own to remember what I said. But anyways, to do this relief, all you do is just create a circle that snaps to the corner. Okay, I'm going to make them equal now. I'm going to hold shift and hit equal so they're the same. And I'm going to set the diameter. So this is the radii, which is 1/16. Just multiply by 2 to get the diameter, which is 1/8. I'm going to hit the line, the exit tool here. And I'm going to go ahead and use the extrude cut tool now. So I'm going to go features, extrude cut. I'm going to select that sketch, and it's going to be up to surface, up to this surface. Click OK, and now you have the relief. The reason I did this in 2 steps, here's the relief, here's the cut. I could have done this all in 1 step. The reason I did that is because I didn't want to mess up my trims, mess up my lines. It would have made a much more complicated sketch if I did this in 1 step. So it's just much easier to maintain to kind of keep this as 2 separate steps. So the next thing we're going to work on is the counter bores that you see here. So if you remember, you got to use the whole wizard tool for that. Okay, so we're going to set the position on here. I'm going to hit Control 8 again to make my life easy. And I'm going to add a center line midpoint to midpoint like we've already talked about. And I'm going to put 2 of these. So I'm going to click this point tool and then click again. So from here I got to add 2 dimensions, as you can see. 3.375. Then I'm going to put one here, 6.375. And we make sure that these are snapped so they're good. If it was still blue, I would drag it till it snaps to that center line, so we're good. So now that we've defined the position, we gotta define the shape. So this is actually a custom counter bore because these are not used for a clearance hole on a socket head cap screw. They're actually just used to slide dowel pins so that the Geneva cam can spin. So we're gonna change this button here. You see, so we're still a counter bore, but we're gonna change this button. Alright, so if you remember on that lecture on reading this nomenclature, we talk about what means what. So this is the inner hole, which is that top piece. Then you have the counter bore head, which is 0.373. And then the depth of the head, which is 0.688. Okay, and that's what it looks like. And that's it. You click OK, and there it is. Tell you what, we're going to use the whole wizard tool again, only this time it's going to be for the side here. Take care of these 2. So we're going to go to the position, and we're going to hit Control 8, and I'm just going to add 2 of these tapped holes. And I'm just, oops, don't snap to that mid-plane, the midline. That's not good. I'm just going to draw a center line to set a point of reference. I'm going to snap this there, snap that there, and I'm going to add a dimension. Again, you don't have to math anything out. The drawing says 1 inch. Okay, 1 inch. Again, I don't know why I didn't snap, so I'm just, because I didn't set a dimension. So I'm going to set a dimension to here, 0.25, and then I'm going to set another dimension here. This one's going to be 1.25. Okay, you understand that? I'm just using these numbers. Alright, we know their location. Now we got to set the type. It's a tapped hole. Again, when I say tapped, I mean threaded hole. Okay, internal threads. It's all the same word. So we're going to use this. And let's see, it's a 1032. 10's the OD, 32 is the TPI, which is threads per inch, so it's 1032. And what else is this telling me? Okay, the depth, alright, 75, see that? 0.75, that's the depth of the inner hole. And we gotta spell that. So the end condition is gonna be blind. It's gonna be 0.75, that's the inner hole. Remember, the top line is always the inner hole. And then the bottom line here is the threads. So the threads is going to be 0.5. This number should always be less than that number. The thread depth should always be less than the inner hole depth. Okay? And keep it like this. Keep the threads dashed line. And we don't need a thread class. Okay? We don't need to spell that. This is going to be a very standard thread. We click OK. And there it is. And you can even see the dashed location for the threads. So, again, we work smarter in this class, not harder. So I don't want to see you do the same thing on this side when they're symmetrical. If it's symmetrical, you're going to use the mirror tool. Mirror, and here's how this works. We're going to pick the front plane. Do you know why this front plane is in the center? It's because when I created my initial sketch, I snapped to the origin. I did it on purpose so that I can take it, so I can use this plane to my advantage. So anyways, you got to pick the plane of symmetry, then you pick the features to mirror. It's going to be this whole wizard here. Click OK, and there it is. You see that? Mirrors it over. Okay, the last thing we're going to do with this is we're going to add properties. So we're going to go to File, Properties, and we're going to type in these 3 items, because that's what's going to extract from this model when we create the drawing. We're going to type in description. I don't think it's case sensitive, so it's okay if it's not matching the same case. No, not name, print number. Okay, so just copy exactly what you see on this template. Print number says sg02 prt-01. Material is going to be aluminum, and the description is going to be sg02 part and study guide. Okay, so add those 3 properties, and you are now 25% done with this final exam. So we're going to save as, and let's just save it as part. Okay, so now you're ready to create the drawing. So remember, I want you to download this. Don't create a new one. I mean, you can create a new one, but then you got to set up the template and do all these things, and then you'll get problems. You'll forget to create a tab and things like that. Make your life easy. Download this drawing, and you're going to get this with the 2 tabs already set up, the template, and all of that. So from here, really, we're ready to create the drawing. And again, I'm really just doing what we went over already. This is just part drawings. Okay, I'm going one lecture at a time. This is all review of what we've already talked about. But anyways, I'm going to import that model, and it's going to be model view. And there's the part. Let's see if that works. Yeah, there it is. That's the one I just created. Otherwise, you'll have to browse for it. So let's go back to our template here. Let's take a look. Okay, this is what it looks like. So this is not the correct projection. So I'm going to click on project view. See what we get. Okay, you see how that looks? So this is that. This is that. Let's see if our scale is correct. Scale should be 1/2. Let's see what the scale is here. Yeah. Whoops. You see how it says 1/2? So this is good scale. Alright, let's see what else we got. We have some sort of isometric. I'm going to hit the projected view, and I'm going to project it here. And again, I already talked about all the details and all the things you can do with drawings. So I'm not going to go over that again on this video. I'm just going to kind of click the buttons that I need and do what I got to do to complete this. Let's get the easy stuff out of the way first. Why don't we add the notes here. Okay, so I'm just going to go to annotations, note, and I'm just going to type exactly what I see there. So here's the notes. Okay, I just kind of typed what I saw there. Next thing you might want to do is to update the template. So that's File, Properties. So you can put your name there. Okay, then the date and 1/2 for the scale. And these really should be capitalized. Not that it's gonna have a problem with identification, but usually on a detailed drawing you keep everything capitalized. It's just part of like that nomenclature. Another thing I want you to notice is, did you see how these 3 items populated? That's because we added those properties. And if you ever want to change those anytime, right click, hit open part, okay, and then hit File, Properties, and you can change these to anything you like. So if I hit A, B, and C, Alright, watch what happens when I go back to my drawing. See, it's changed to A, B, and C because those are linked. Again, the reason I designed it like this is because when you work with a lot of files, a lot of models, you want the information pertinent to the model to stay with the model, and you want the information pertinent to the drawing stay with the drawing, okay? And again, I already talked about that during the part drawing lecture. Anyways, let's start adding the dimensions, and let's get this thing going. Alright, so what I'm going to do is add this, I'm going to click the Smart Dimension tool, and I'm going to add, you know, exactly like what you see there, you see? So it's just, can you make it look like what you see here? Okay, so I'm just going to go ahead and add a dimension everywhere I see it. And if you remember, really, these dimensions follow everything that we learn about the rules. You know, keep the dimensions between the views. You know, keeping things organized, keeping things clear. So all those rules are applied in this design. And this is actually a pretty realistic model. This is yeah, it's pretty realistic as far as the tolerances and the way it looks. For these holes here, we're gonna use the hole callout tool. And again, the reason why we can see all this nomenclature is because we used the hole wizard. So that's why we were able to do that. Also, we need a center line, so go ahead and add a little dimension here. And I'm gonna add one here as well. This is mainly for the symmetry. Okay, I do need a CL symbol though to show its symmetrical line. This is not a symmetrical center line, so I don't need it there. I do need the hidden lines here. So you do that by changing the shade. When you change that shade, you see how the hidden lines show up. Usually I don't include the hidden lines on an isometric, but in this case it's not really crowding the design. It's not really confusing the machinist, so I'm gonna actually leave it there. Okay, if it was getting kind of crowded, I wouldn't do that, but in this case it looks pretty good. I'm gonna add center lines here. I'm not gonna use this tool though. I'm not gonna do it like this. I'm gonna use the other. Actually, you know, don't even bother with these. Just type in center line. Yeah, this is the one I want, because this one again lets me kind of figure out the symmetry in one shot. So I really like that. I'll tell you what. I'm gonna do that again on these ones here. Also remember, if lines look symmetrical, I'm sorry, if two center lines align, so there's a center line here, there's a center line here, make sure that you connect them. Or just draw one continuous center line like that to show that they are aligned. Okay, it's just common nomenclature. And we talked about that when we went over orthographic projection and all the different kinds of center lines. What I'm going to do now is worry about the tolerancing and some of the minor details. So here you can see there's a tolerancing on the head diameter. So you gotta look at this. You gotta look at counter bore diameter, and you can see that it's a bilateral. Let's take a look. Plus 0 minus 0.2. So plus 0, 0, 0, I'm sorry, 0 and minus 0.02. Okay? So that's important. All these tolerances are important. The reason this is such a tight tolerance is because it's using a press fit. Interference fits are very delicate, and you do need that to be very tight. So this is to bypass the block tolerance that you see here, because this is a much more specialized tolerance. Okay, that looks good. Notice the decimal place. Okay, you see how everything is 3 decimal places? If you ever want to change that, you gotta go to Documents, Properties. You can change this. If you do 2, alright, it changes everything to 2. If you go back to that and you do 3, changes it all back to 3. But let's say you need one to be 2. Like for example, if you zoom out, you see how this one's 2? Okay, you gotta click the individual one and change it directly here. And click this one to 2. This these decimal places are important. They communicate something very different. If you put 2 decimal places or 3 decimal places, you communicate a whole different kind of tolerance. So, so do pay attention to that. So that looks good. That looks good. Okay, I'm just gonna clean this up and dress it up a bit. Okay, do you see how this is this way? You can do that by clicking this arrow. You can get it out of the way like that. Okay, just to kind of even out your space a bit. There are some pretty tight tolerances on these three. This one has a symmetrical tolerance of 0.002. By default, it's 5 thousandths, but we need something a little tighter for this Geneva cam to work. So what I'm gonna do is add that tighter tolerance that you see there. Okay, so just like that. Okay. I'm just gonna move that over there just to stay consistent. That looks good. What else? Yeah, that looks pretty good. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Okay, that was good. Let's check out the side view. 1, 2, 3. Okay, stock just means you can use the stock size from the bar stock. This is good. This is good. Let's check this out. It's got an MFT. So remember, that means minimum full thread. Tells you the threads can be at least, can be more than this until it hits bottom. Okay, that actually looks pretty good. I'm gonna go ahead and save this. Save as. Let's call this drawing. Okay, so we got a drawing so far. We have a part. Okay, SLD PRT and an SLD DRW. So we are officially done with the take-home version. Okay, again, so you're gonna do exactly what I just did, only for this. Okay, that's what this is. So now we're going to talk about the in-class portion, which is to create the assembly. So pretend that you are now coming in the class, you're ready to take the exam, okay? You're logging in to Oswald, and you're ready to do the assembly portion. Okay, so I've downloaded the parts files, I've extracted the zip, and now I'm ready to build my assembly. And I should be, if we go back to the instruction sheet, now we are going to build the assembly with the provided assembly drawing. So what I gotta do now is do a new assembly. So again, pretend this is the in-class portion. Okay, now I'm on the clock. Okay, I got an hour and 50 minutes to do the rest of this exam. So let's see. The first part I'm gonna bring is what I created. That's the only part that you have to create, which is this. Everything else I'm giving it to you. The reason I designed this exam like this is because I want you to understand how a part that you create integrates with off-the-shelf hardware and how it all interconnects with the part and the assembly drawing. Because again, that is what companies want. That is what they describe in the job descriptions. That is what I did for 10 years. This is why I set it up this way, where you import your own object, okay, into this. So anyways, this is an assembly. I'm just going to change the background to white. And if you remember, when you import the first part, it fixes it. There's a way to center this without using the mates. I already talked about that, so I don't need to review all that. I'm just going to do this the way I feel makes the most amount of sense. But if you want to know about the other ways of doing this, I already talked about that during the other lectures. So we don't need to go over that again. But anyways, what I'm doing now is just adding a mate. I'm just shift selecting each plane and adding a mate so that it's centered, so that these planes are centered about the object. Next thing I'm going to do is import all the other parts. So that's going to be all, you know, wherever you saved those parts. So I'm just going to bring all of these down. Let's see if I can. Okay, I'm just going to lay these out. Okay, so I've laid out all the pieces here, and what I'm going to do now is actually just save this. Oops, I'm going to save it as an assembly. Okay. And I'm going to start to add mates. Okay, so that's really the main tool of assemblies. So there's going to be a concentricity mate here. And again, really just assemble this how you would in real life. I mean, obviously this is going to hit bottom over there. This is going to be concentric about there. So you can flip that if you want. Or that was not correct. I need to delete this mate. This does not go there. Move this out. It's actually the Geneva cam that goes inside here. And then this is going to hit bottom over here. And then we need 2 of these, right? So we're going to hold control and drag. We're going to do that again for the bearing. Hold control and drag. And now, let's add some details. I don't know if I went over this in a previous video, but when using these mates, mate these how you would mate them in real life. So you see how I'm mating this against this? I'm not mating this against that, because in real life this is not what's holding this thing down. It's not this. It's the bolt that's holding it down. So mate the piece like it would be mated in real life. The reason I mentioned that is actually I made a mistake once. I was very young and I was new to a lot of this. I was doing this. See, I was mating a surface like that, and then I didn't check to see if the holes would align. And then after the parts were machined, it was off. Probably a really stupid mistake. Okay, I mean, it was you know, you want to double check and triple check this kind of stuff. But I'm just giving you some pointers to reduce the number of mistakes. So if you follow certain techniques, you are less likely to make mistakes. Because sometimes this stuff gets a little redundant and you forget to pay attention to some of the details. So you gotta be very careful with that. Because a lot of mechanical engineering is actually making stuff fit, and a lot of times it gets redundant. You kind of lose track of the overall assembly, and that can give you problems. I don't really like all these construction lines, so I'm going to turn them off by going to view hide all types, so it makes my life a little easier. And I'm going to bring this bolt in. I could have used mirror components. Okay, that actually would work if I copy the 2 bolts to the other side. So if some of you want to try that, you can do it this way too to save you some time. Maybe you're running out of time on this exam and you want to copy the bolts. You're more than welcome to do it that way if you want. Okay, so really I'm just putting this hardware inside. So now I'm going to make sure this goes where it's supposed to go. Pay very close attention to what I select. Everything I click, it's for a reason. Again, I've probably made every mistake you've done 1,000 times. And over time, I've realized certain clicks are more successful than others. So when I select a surface here, when I do this, there's a reason for it. It's to make your life easier later down. So, So one of the other nice things about SolidWorks is that it's not only just good for getting a job, but it's also good for any of your personal projects. Like, let's say you want to design your own house, okay, and you want to build it from scratch. I mean, how cool would that be? Design, you know, the rooms, design the frame, the bathrooms. You can use this tool to do that. You can figure out exactly what length to build your wood, or what sizes, you know, this structure needs to be this, you know, this frame, this deck. So you can, it's a tool. It's like reading and writing, okay? It's a way to communicate something you have in your head on paper and turn it into a reality. So now I'm just adding the mate on the handle here. I think most of this is kind of self-explanatory. Okay, so this looks like it's maybe welded in. And I need a retaining ring. So again, I really like these. These have really improved my designs over the years. Okay, so I was afraid that would happen, but I got kind of lucky. There's the worm screw. Okay, so you can. Alright, let's just kind of go there. Looks good. Alright, this is the pin that slides in. Okay. And this goes in here. That goes in here. Alright, let's take a look at what we have. So here's the cam. There are many different mates that I can do to make this cam do what it's supposed to do. I just don't want to go to that level of detail right now. There's the power dynamic contact tool and the move tool, and then there's the tangent tool that you can use, or you can even use the motion studies, but I really don't want to go into the details of that right now. I kind of just want to show you that dowel pin. You see how there's like a clearance hole here? It's so that this can slide, and then here there's a tiny interference. And I can even measure it. Okay, you can use the measure tool to see, like, hey, what's the distance between those two? But it's very tiny, just a few thousandths of an inch. And then there's a clearance hole in the bottom, so you can pry it open with a pin. Just because sometimes you want to replace these, and it just makes it so much easier to pry it open. Or if there's like some sort of goo that gets stuck in there, you don't want to just let that sit. So it's a nice relief hole to clean that up. So anyways, that's the assembly. Now what I gotta do is add an explosion view and explosion sketch lines, and after that I'll be done with the assembly file. Okay, so to begin the what you call it, the explosion view, I'm just going to add a lock. I've already talked about why I do this in my previous lectures. But I'm just going to create a lock here just because I do not want my explosion to wear out, to misalign. This one's going to be a little weird, okay? You ready? Here's what I'm going to do. I'm going to put a 45 on the side. Okay, just so you get a very clean... See that? Look how perfect that is. See, that's what I'm talking about, okay? So... I'm gonna, okay, once it's clean like that, once it's slide, obviously I can't well, I can, but don't go crazy with the mates. So again, you're taking an exam, you don't have that much time to worry about the perfection of these mates. At the end of the day, I'm just looking for this drawing and then 2 models, that's it. So let's talk about how we're going to do the explosion view. Again, this is all spelled out here, and we're going to just make it look like what you see here. Alright, so okay, this starts by moving this pin out, then this goes out, okay, just like you would in real life, okay. Then, oops, see, I made a mistake. You gotta pull the pin before you pull this gear. Okay, so not too much. We don't want anything to interfere. Alright, let's see what else. Here we have 2 of these. Again, just eyeball it. Just eyeball it for now. It's all about clarity. You want to communicate how this thing gets put together. Okay, that's the goal. You got to figure out how to make this as clear as possible. Okay, you got to put yourself in someone else's shoes. Someone that's kind of new to this stuff. You can say, all right, if I was new to this stuff, would this be clear? What would I be confused about? So that's don't be lazy about that. You know, be very careful on how you communicate something. So then what I'm going to do is round off these numbers. Okay, so it's 5. I'm going to round it off to 2, apply down. Make sure to hit apply down, otherwise it won't save. So yeah, I'm just rounding off the remaining numbers. Yeah, okay, that's good enough. Okay, it doesn't have to be exactly like this, just close, but it's got to be clean and it's got to be consistent. That's what they would always tell me as an engineer. It's like, it doesn't matter if you used to put a period or not at the end of at your slide decks. Is it consistent throughout? That's what's important, and that kind of stuck for a while. So yeah, again, with these drawings, really, it's a lot about communication. You got to understand how to make something clear for someone else. It's kind of like saying if you're trying to teach that A equals C, uh, you have to tell the person that A equals B, B and B equals C to know that A equals C. But if you just say A equals B, you'll never know that A equals C unless you say B equals C. And what I'm trying to say is a lot of times engineers, they forget to mention all the steps needed to figure out what you gotta do to get what you need, what you're trying to instruct. Um, so that's what I'm saying. Like, think of creating an explosion view that's easy to read, that makes sense, that's not too confusing, that's not giving too much information, that's not giving too little information. So I don't know why this thing is jumping around so much. Okay, good, good. Okay, so what I'm doing is essentially I'm just looking at that number. I want to see if it's divisible by 16. All right, looks pretty good. I'm gonna click OK, and let's see what we got here. Okay, I'm just gonna bring these in a bit, just so it's a little more symmetrical. Okay, otherwise it looks pretty good. Remember, all your explosion views are saved here. I don't want to see 100 different of these. Okay, on your tree. Okay, again, it's the third tab. 1, 2, 3. It's the third tab. It's inside the configuration. And these are all my steps. If I ever want to edit that, you hit edit feature and all your steps are there. Okay, so that's good. I like it. And again, you can switch between the two states. Again, these have nothing to do with the mates. You just hit collapse, you hit explode, and you can switch the states. It depends on which configuration you're on, though. I'm on the default configuration. If I was on another one, I would not have access to this one. Okay, so I got a little note here that I gotta save this, so I'm gonna do that. So now we said we need explosion lines. So again, it's gonna be very simple. Again, make sure the arrow points towards the inside of the assembly. This is gonna connect to the bottom right there. Tell you what, I'm gonna put another one here. Change the arrow. I don't know what this is. Ooh, that's kind of... All right, there it is. And maybe one that connects these two. Oop, see, I'm gonna... You can hit the reverse box here too if you want. And maybe I'll put one here as well. Okay. And one final one. Alright, very good. Okay, I'm gonna click OK. I'm gonna exit out of the sketch lines. There they are. Let's hit Control S to save. And we are now done with 75% of this exam. The final part now is to create this assembly drawing. Alright, so if you remember, this is where we left off on our drawing. I have a second tab here for the assembly that is blank. And what I'm going to do is actually import that assembly that we just created. Okay, so really my goal is to make it look like, you know, what you got here. It doesn't seem to be projecting, so I'll use the project button directly. I'm going to select this view and delete it. Let's see, it's 1/2, so we're going to increase this to 1/2. I'm also going to turn off the tangent edges. Okay. Sometimes they do include them, but a lot of times they don't. Okay, I guess that comes down to personal preference sometimes. Okay, I need to add these fields. I forgot to do that. So I gotta go back to my assembly and I gotta add properties. So this time it's gonna be description, material, and print number. Okay, I'm going to just put A, B, C for now. I'm sure you can read through these and type those, and there they are, A, B, C, so that's good. Alright, I'm going to add the notes as well. So, I'm just going to type exactly what you see here. Okay, so as you can see, I just typed the notes. Next, I'm going to add a table. You got to select the view. And you're gonna add table, insert tables, bill of materials, top level, and I already talked about what the other items mean, but we just need to pick top level. Okay, this is filled out, this is good, so we gotta work on this table now. And you gotta click on this blue section. Here, let me zoom in. Okay, and we're gonna add insert a column left. This one's gonna be print number. So you understand where I'm coming from. I'm just looking at this and typing in print number. I'm gonna insert on the left, and this one's gonna be description. I probably should select the uppercase. It's the same one because it's case insensitive, but like I said, this should be all uppercase. I need one more here, which is the supplier. Okay. You can see I didn't include a supplier for this part, but that's okay. I can do that if I want to. You just right click it, open part, and just add supplier. I really should. Okay, so let's just call it D for now, just to understand. We go back, and there it is. There's D, A, B, C, D. So hopefully you understand how this interconnects with the parts. Again, any of these you want to change, you right click and you hit open part and you add properties. But you don't go in these boxes and you don't do this. You don't just type stuff. That's not the way this works. I mean, that's how it was during the AutoCAD days, but not with this new method of modeling. Okay, it's just not the way you do this anymore. Yeah, we said we got a little bit of space here. I'll try to maximize. Move this to the side. So now I'm going to add a balloon. Again, don't use the auto balloon. You'll just end up doing more rework. And I usually go through each of these items, okay, and make sure I look at the pink and then I add a balloon. But since I already kind of have a diagram here, I'm just gonna follow the diagram. But I'm just saying, like in the industry, you would probably use that method. Okay, I'm just gonna go all the way around. I see one there. Alright, so now that we have the icons, I'm just gonna kind of dress this up. You want to always be professional, never submit something sloppy. I remember once I was working on this cabinet. It's an electrical cabinet for a transfer machine. They're like huge, $3 million, probably the biggest machines I've ever seen in my life, and I was doing some electrical mod on them. And I was using a Sharpie to label the wires, and they're like, "What are you doing? This is unprofessional. You gotta use this label maker." It's kind of like when you look at the roads. Would you want to see a stop sign with a Sharpie that says stop? It doesn't work like that. You gotta always be professional. Everything has to be very industrialized and very clean. It's gotta be very organized. Anyways, okay, that looks good. I'm pretty happy with that. I'm just gonna hit save. I don't know what that is, but we're just gonna click save, and we have the completed drawing. So we're going to do a save as, and it's gonna be PDF. So it really doesn't matter. Let's just call it drawing PDF, okay? And we're gonna hit save. It says, hey, do you want to bind the two pieces together? And we're gonna say, yes, we do want to do that. Okay, and then so this is what I just created. So as you can see, the template's filled out. It looks somewhat close to the study guide instruction sheet, okay? So now I have all the pieces, all right? So I'm going to log in, right? I'm ready to submit this. I have all the pieces. So I'm gonna log in, and we're going to go to the submission button. Okay, so we're gonna click on fe01, and again, these are the three slabs. We type in the mass properties for the block, okay? That was this. We go to evaluate, mass properties, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 5 decimal places. Plug that in. Exam assembly. We go into our assembly. Alright, it's going to say, hey, suppress this, suppress that. You're going to find out from the icon. It says, hey, suppress this, suppress that. Right click, suppress. Right? If we click on it. I already talked about this, but just in case that's still kind of confusing. Okay, suppress whatever red items are showing up. And fill out the mass properties. Okay, and then finally you browse for the PDF, that binder, that combined file. You browse for that, and then you hit submit. As soon as you hit submit, it's going to check this, and that. And if you get an error, it's going to say, hey, this is bad, this is bad. Okay, it says this format correlates to this. This size correlates to that. So so it's gonna warn you. If for some reason you have some serious issue and you cannot submit, just bypass it. But that's a very small chance of happening. Uh, the reason I have all these controls is because students were sending me so much garbage over the years. Like, I'd get like a JPEG one day, another day I'd get like a movie, another day I'd get like, I don't know, like a photo from their phone, and a lot of times the students would misspell their names, they'd type the wrong student ID, and it was just a mess. So the reason I have all this is so that I get a clean submission on the archive. But anyways, when you have those three items, you hit submit. That's it. You hit submit and you wait. Okay, it's gonna process your files. It's gonna run the grading algorithms. It's gonna send the files to an archive server. It's gonna send the files to your email. So there's a lot of things that it has to do on the internet to pull this off. So be patient and wait for the meter to finish, and then it's going to give you confirmation, and then that's the end, and you will be done with a class. 48 hours after the deadline, you will see your grade, and it will show up on the grades button, and that's the end of it. That will conclude the class. And again, if you have any questions during any of the any of the grades or any of the submissions or any parts of this exam, just let me know.